We propose a haptic interface moving press. Our interface uses a leg and pinion mechanism combined with phantom sensation to create the feeling of pressure movement. Based on our device activation, the point of pressure sensation is continuously moving. In virtual reality, users naturally experience touch during the interaction. Haptic feedback not only conveys essential information about virtual objects, but also fosters emotional connection between users. We leverage tactile illusion to deliver pressure movement. However, most studies on tactile illusion have focused on vibrotactile rendering. Moreover, a few pressure-based tactile illusions have been limited to the forearm, leaving the hand largely unexamined. The contribution of our study is as follows. First, we investigate the pressure-based phantom sensation on the hand. Second, we propose a novel leg and pinion-driven wearable haptic device. Third, we implemented a pressure-based moving phantom sensation. Finally, we conducted the user study and suggest the rendering method for natural sensation of pressure movement. We designed a leg and pinion-driven wearable haptic device to render pressure-based moving phantom sensation. The indentation depth is controlled by rotating the pinion, which drives the linear motion of the leg. To ensure stability during operation, the user's hand is secured using a hand support and a Velcro strap. User wear a wearable haptic device on the owner sided hand and receive the pressure feedback. The device activated based on each haptic scenario. In this study, we formulate two research questions. First, can we induce pressure-based phantom sensation on the hand? Second, can we induce pressure-based moving phantom sensation on the hand? To address this question, we conducted 3 perception studies and a user study. For our perception study, we developed a grounded haptic device. We secure each participant hand with Velcro strap and deliver pressure feedback with a linear actuator. The purpose of the perception study 1 is to answer, can we induce pressure-based phantom sensation on the hand? Our first study shows that with a 2 cm spacing between actuators, the likelihood of evoking phantom sensation exceeded 80%. Additionally, users tend to perceive the pressure feedback biased in a proximal direction. We confirmed the occurrence of pressure-based phantom sensation on users' hand. Next, we investigate whether difference in the indentation depths of 2 actuators induce the shift in perceived location. As shown in the graph, the average perceived location consistently shifts toward the actuator delivering higher indentation depths. In our next study, we compare the intensity of the midpoint stimulus with phantom sensation. The results showed that across all the conditions, normalized threshold is approximately 0.76. For the user study, we vary the indentation depth variation profile and assess user experience using 2 metrics, consistency and continuity, to quantify how smoothly and uniformly the moving phantom sensation was rendered. Participants wear our haptic device throughout the study, with the GUI as shown. The logarithmic profile yielded the highest consistency rating. For continuity, participants rated both the logarithmic and linear profile very highly. Our device delivers pressure movement feedback and can be applied in a variety of scenarios such as handshake, striking, manual therapy, and navigation aid.